So find the probability of football given females. So go back to number one. So we know we're only looking at the female row. There are 13 in the football slot and 52 total. So this is 13 out of 52. Or if you reduce that, that's actually a fourth. But you don't have to. Probability of male given basketball. So I know I'm in the basketball column. 15 males out of 31 total. Probability of baseball, so now I'm not giving you anything, I'm not isolating it, I'm not narrowing it down. It's just in the whole chart, what's the probability of baseball? So 36 out of, there's 100 total in the chart. Those three okay? Second one, are liking snowmobiles and liking skateboard mutually exclusive? No, because you got 80 people that said they like both. So remember, mutually exclusive means cannot happen together at the same time. So for example, passing this class and failing this class, are those mutually exclusive? Yes. Passing this class and getting an A in this class, are those mutually exclusive? No, because you could definitely pass A and get an A, right? Probability like snowmobiles, so again, I'm not narrowing that down, I'm just saying like in general, what's the probability that someone likes snowmobiles? So it's 105 out of, there's 160 total. Those two good? Alright, so this one seemed to trip some people up, but I think we kind of got it. It's really tempting to just put 35 and 45 in those circles, but then it doesn't work. So if you put 35 here and 15 here, your chem circle would then add up to 50, and that's not what we want. So I always start with the both. Put 15% both in the middle, and then I know the chem circle has to be 35% total. I've already used 15% of that, so there's only 20% left. Same idea with the other one. The physics circle has to be 45%. I've already used 15% of that. There's only 30% left. And then this whole box has to add up to 100%. So you got to put a number somewhere in the space on the outside. Right now I've got 20, 50, 30, so 65% on the inside, so then 35%. What did these 35% do? They passed both, right? They didn't fail either class. So probably someone failed chem would be 0.35. Failed physics is 0.45. Failed both is 0.15. Failed neither is 0.35. Failed chem again, I have to do that. And then are they mutually exclusive? No, because you could fail them. You could really regret your science class choices. Questions on that? Alright, so go to the packet I just handed out. Then there's a page on with a diagram. There's a page that says Venn diagrams at the top. I want you to do that page. If they're over there, it says like probability at the top. On the table behind Sam. I can get it for you in a second if you want, or you got it? So this page here that says Venn diagrams on it, I want you to do that page. Everybody say hi to Peter. He's up. He's going to watch the video. Hi, Peter. He'll be so excited. sure you label your Venn diagram. I think that'd be kind of easy to forget which circle is which. Is this the first year of NCIS?
Huh?
Is this the first year of no NCIS?
Yeah, just admitted.
So there's your first one. You got a box?
On that one. The other one. I don't see the point of making a box.
The box represents 100% of the data. Is inside of that box.
You see the numbers that represent 100% of the data.
You can do it your way if you want, but I'm gonna work it wrong.
Yeah. If a box is worth that much to you, I will make sure I put a box on it.
You put percent. If you put percents here instead of decimals, that's fine. Sound good? You put percents instead of. So you think because you ran a 5-1, you can do whatever you want now? When's the next board meeting? Oh, really? So you might not be able to make it.
Yeah. So I'll probably just go to the workshop. Because I couldn't go to the last one.
Do you get like the agenda in advance? What's that where they do it tonight? I might be yelling and screaming tonight.
Allie will be there, so.
That's good tomorrow. And that'd be kind of awkward to walk in the middle.
Yeah, while we were streaming.
I mean, hopefully that's not happening, but.
Oh, I was like, no, I'm good. I'm good. No, I'm good. That's so cute.
So there's your second one. And again, if you're putting percentages, that's totally fine. 3. This one? Doesn't play sports. So I just looked up here and it was like 70% play sports. So that means 30% don't. Or you can look at like this, the sports circle is 0.7. So like not the sports circle is 0.3. Like that one. Question on this one? Anyway? Where'd you get this number from? Why'd you do this? Percents are okay. I'm just lazy. A decimal is easier to write than a percent sign.
Okay. Nothing. There's nothing.
Okay. Logan.
Oh, never mind.
You good?
Huh?
Nothing big?
Now I hate that there's like 2 sections of public comments. It's like everyone was just like, and like I don't care like the first section or the last section. I'm like, alright, I just want to go.
It just goes on.
Yeah, like.
Alright, go to 6.3C. Just a couple pages down the road.
Oh wait, his self-evaluation is on.
Oh, that's interesting.
I looked up the thing.
And just do 5, please. Just do 1, 2, 3, and 4. We haven't talked about 5, 6, and 7 yet. Just 1, 2, 3, and 4. I feel like the class height really suffers from that. Much less.
I miss him like running down the hallway here in this month. When I worked 6 hours or 5th hour.
Really?
Yeah,
He runs in the hallway
Yeah, he runs. Like, he
to get to his next class.
Yeah, he runs. Like he's like,
He always stays in here like 2 or 3 minutes after.
Back in the middle school,
Maybe
I
that's
see
why.
him run through the halls with his clarinet case.
He's like swinging all over the place.
Yeah.
he's so funny. Looking like breathe. So we know.
We good on these? Okay. So what's the probability they're a woman? So there's 856. And then the total is 1626.
Yes.
Probability they're a man would be 770 out of 1626. Goodwill. What's conditional probability that you choose a woman given that they received a professional degree? So we're only looking at professional degrees. 30 of them are women, so 30 out of 74. And then conditional they received a bachelor's given that they're a man. So we're just looking at the male. And there's 529 that got bachelor's and 770 of them. Those okay? Yeah.
Alright, so that's you got the right thousands.
What do you mean? Oh, I didn't even notice them, no.
Yeah.
Because, like, the probability, like, really, okay, so if you want to say it's like 30,000 over 74,000, I would be like, well, I just reduced it. So, it wouldn't really matter, you know. I neither. Alright, go back to the front page. Some of this we're not going to worry about as much. You do have to know what these two words mean. So, I mean, that is kind of okay, I guess. Probability is how frequently something occurs over the long run. So the long run is like the big term that the big idea that they want to get across. So, if the problem, like if I flip a coin, what's the probability it comes up heads? 50%, 1/2, right? But does that mean that if I flip one and it's heads, then the next one's going to be tails? Like, does the coin know, like, oh, I was just heads, so I have to like make sure tails next to it. Like that's not how it works, right? So it's over the long run. So we don't know what's going to happen over the short run. I can get 7 heads in a row, but over the long run, it's going to be 50%. So that's the big idea there. How frequently something occurs over the long run. 0 means it never happens. 1 means it always happens. Random is the same idea, the same like concept they want, so it's predictable in the long run. So coin flips are actually random. Like if I flip a coin and put you in a group, that's random. I don't know what's going to happen on this flip, but I know if I do it a billion times, I'm going to be right about at 50%. So that's the big idea they want to get across to you is probability is over the long run. Right? So like this happens with weather all the time. Like, well, they said it was an 80% chance it was going to snow, and it didn't snow, so weather people are stupid. No. Like 80% of the time over the long run, so 20% of the time it's not going to happen. So you can't look at it and be like, happen. They said it was. They didn't say it was going to happen. They said it would happen like over the long run, 80%. You know what I mean? So people like overreact to short term situations, I guess. All right, probability tree. I want to show you how to do this. So I have a coin that lands heads 60% of the time. We're going to do a tree diagram for flipping it twice. Flipping twice. Count the number of heads we get. So this is a pretty common way to find a probability. So we're going to say I've got flip a coin once. There is a 60% probability that it comes up heads. There is a 40% chance, therefore, that it comes up tails. And then if it came up heads, I'm going to flip again. There's a 0.6 chance. The second one was heads. Chance that the second one was tails. If it came with tails, I'm going to flip again. There's a 0.6 chance that the second flip is heads. 0.4 chance that the second flip is tails. And then we can kind of summarize this. You would say, I can't this up well, but the probability of heads follow that path, and you multiply those two numbers together. The probability of heads, 0.6 times 0.6, which is 0.36. So if I have this is an unfair coin, somehow I know it lands heads 60% of the time. And I flip it twice, the probability I get heads both times is 0.36. The probability of heads, tails, follow that road. 0.24. Probability of tails. So you just got to keep going on the line. So tails heads. 0.4 times 0.6, which is also 0.24. And then tails. 0.4 times 0.4. So what should all of those numbers add up to? Should add up to 1. That's like the only possibility, so it should represent 100% of the possibilities. So then a probability table would say x equals the number of heads. X, b of x. So what are the possibilities for the number of heads? I put 2 coins. How many heads could I get? I could get 2. That's the only option. Could get 1. Okay, get 3. So what's the probability that I get 0 heads? So look at this information over here. What's the probability I flipped it twice and I didn't get heads at all? This guy right here, right? Tails. That's the only way I got 0 heads, so this is 0.16. What's the probability I got heads once? You gotta add up those two because there's heads once in that one and in that one. You know what I'm saying? 0.24 plus 0.24. one's probably like it hits twice. 6. That makes sense? Okay. Yeah, okay. Go to the next page. Whole lot of room for you to do a much bigger one. I'm gonna flip it 3 times this time. And it's a 70%. I want you to do exactly what we just did. You're just gonna have like off of these, you'll have another branch there, another branch there, another branch there, another branch there. Do all your calculations and make a table like to sum it. Make something I'm asking. Stop looking at me. There's kind of your general. I'm not like doing the math part you got, but there's your general setup and what I'm looking for. Sorry. I don't know where it is. Just saw it before. I think it's gone. Well, I made a poor choice when you gave it to me. You kept it for 4 years. Within 4 days. I swear I saw it this morning. It's got to be here somewhere. Black one. Just it's like this. I know it's not. You don't have so this split, this split without this needs to split. So there should be 2 here. Oh, right. typing your tree line? Just say, typing your tree. I'm sure you will. I know how to teach this stuff. So I just know how to do this stuff. I know. I'm just. Do you pick it up? You can point 7 to the third in your head.
Would I still want to write HHD if I had HTH?
Yeah, they're different. So, like, this is a coin that we're flipping over and over again, but eventually this will change, and, like, if, so for example, if I have COVID, the probability I'll test positive is this, and negative is this. If I don't have COVID, I still might test positive or negative, and there'll be different numbers, so it will matter. Like, I know that HHT and HTH are going to be the same number, but eventually they won't. So you want to make sure you keep most of them. Okay. What is it?
Shake your. I checked it after I did it. I checked it. Don't shake your head at me.
So you can just do like 50 times 7. Try something more. It's not even.
I just straight up multiplied. You can do 7 times 7 is 49.
Yeah.
Just multiply it.
What does that mean to you straight up? Because you do it like.
I just did 0.7 times 0.7. And then times 0.7.
Trying to understand how you do 7 times 49.
Oh, I just did. So first I did 7 times 4, so 28. And then 7 times 9. 63. Just add the. Yeah.
Well, everyone does it.
Yeah.
So I would do like 7 times 50. You do 350. That 49 is 1 less 7. So it's subtraction. Different ways.
Makes sense.
I'm not saying I just talking about it. You said
And then I typed it.
This looks like
It's on my paper. Did you see me right after I typed it?
there is a black one. It's not as good though.
I like. I just barely clicked it. I did. What card? Yeah, that's what I was looking at. That's why I did. I thought it said.
Yeah, this is a smart, right?
I was like, that was like a student test. It's like. Oh, dude, I know. That was. I didn't touch that. The first time I was like, make sure your fingers on this part. Maui. Oh, it's not that bad. I did whatever. What car is this?
You guys done? Is this what we got at the end? So then I can ask you like what's the probability we got heads 2 or more times. You would just take like the 2 and the 3 and add those up. So yeah, like 0.774. What's the probability? What's probability? Let's do this. What's the probability I got at least one head? At least one. You would add up these 3, or what else could you do instead of adding up these 3? Just subtract that one. Yeah. So at least one comes up a ton on the AP test, and therefore in your test. So trying to start understanding the idea of at least one is like the opposite of never. That makes sense. If you've done something at least once, that's the opposite of having never done it. Questions on this anywhere? Alright, so I don't want to start the next thing. So we are all good for today.
You don't have to write anything until after Christmas break. I know, like, I mean, it's cool. Watch, you're gonna tell us over Christmas break. We have to. I'm scared. I think you might actually.
If you don't put your finger on the back of the that's what makes it connect. It's like if I hold this.
This
Today is try this.
What?
It's my new car key. Now that I pop out. This one goes to that.
really just go down the line. Like, gas fires.
Yeah.
Oh no.
Why does it do that?
It's just a big key.
That's the whole point of that?
Yeah. Yes.
Now you have pieces of gum too.
I did it twice too.
I like barely did it the first time. Now he was.
Did you press it again?
Yeah, I pressed it again.
Yeah, because that's what I did too. I almost went for 3 of them.
It's like it's not like under my finger.
I can still feel it. It's like shooting on my car.
How do you still
I can still feel it.
Fine.
It's like
I'm like, bro.
it's kind of weird.
I just not that much.
I'm gonna walk in tomorrow like my arm back.
I do it.
Guess where it was? Wave check.
Get the thing away from me.
Star Wars.